Hello everyone, in this video we are going to learn about the measures of dispersion. Measures of dispersion describe the amount of variation in a set of data. If the data are widely scattered, the dispersion is said to be large. Common measures of dispersion are range, variance, and standard deviation. We will learn to find the variance and standard deviation for ungrouped data first. The formula of variance for ungrouped data is given as this. The standard deviation is the square root of the variance. Given a set of data, mean equals to the sum of data divided by the number of data. So the answer is 3. We will use this formula to find the variance. We calculate the sum first by using this table, where x sub I is the given data. Now subtract all the data with mean 3, then squaring all the values, and the total is equals to 6. Substitute into the variance formula and the answer is 2. Then the standard deviation is square root of variance and the answer is 1.414. Given two sets of data, we want to find the mean and standard deviation for the data and interpret the values. For this example, we will use this formula. The number of data is 11 for data 1. Then calculate sum of x and sum of x squared for data 1. Then substitute into the formula to find the mean and standard deviation. Data 2 has 11 number of data 2. Now find the sum of x and sum of x squared. Then find the mean and standard deviation. We notice that the mean for data 1 and data 2 are the same. This implies that both are centered about the same value. However, the standard deviation for data 2 is more than data 1, which implies that data 2 is more dispersed than data 1. Now we will find the variance and standard deviation for group data. The variance formula for group data is given as this. And the standard deviation is the square root of variance. In order to find the variance and standard deviation, we had to construct the frequency distribution table. The midpoint is lower limit plus upper limit divided by 2. The fx is the frequency multiplied by its corresponding x. The sum of fx is equals to 2510. Fx squared is frequency multiplied by the square of its corresponding x. Then calculate the sum of fx squared. Now substitute all the values into the formula to find the variance first. Then find the square root of variance to get the standard deviation. The table shows the wages per hour paid to temporary workers at production and marketing department. But we want to find the mean and standard deviation for all temporary workers. So we had to combine the two departments in the frequency table. After combining the number of workers, we had these new frequencies. And the total frequency is 240. The midpoint is the average of lower and upper limits. Fx is frequency multiplied by its corresponding x. And the total is equals to 3116. Fx squared is frequency multiplied by the square of x. Then calculate the sum. Now substitute all this value into the formula of mean and standard deviation to find the answer. The answer must be in Rm. In this example, we want to find the standard deviation and the new standard deviation when the wage of each worker is increased by 20%. Before we find the standard deviation, we had to complete this table first. Substitute all the values into the formula to find the variance first. Then find the standard deviation. The answer must be in unit Rm. After increase of 20% on the wages, each midpoint will be increased by 20%. So the new midpoint equal to the previous value multiplied by 120%. Then complete the rest. After that, substitute all the values into the formula to find the new variance and the new standard deviation. Range is the difference of the largest and smallest observation of the data. In other words, it equals to the largest observation minus the smallest observation. For the given example, we want to find the range for this data. So the range is equals to the largest observation, 96, minus with the lowest observation, 40, and it equals to 56. The coefficient of variation is the standard deviation divided by the mean of the same data set. It is expressed as percentage. A larger coefficient of variation means that the data is more dispersed and less consistent. This measure is very useful for comparing the degree of variation, stability, or consistency of one data set to another. The formula for coefficient of variation is standard deviation divided by mean multiplied by 100%. In this example, we want to find the coefficient of variation, and the mean and standard deviation are already given in the table, so we just substitute it into the formula. We use CV to represent the coefficient of variation. The answer must be in percent. In this example, we want to determine which data group exhibit a greater variability or dispersion. We use the coefficient of variation to solve for this. So find the coefficient of variation for both data. By comparing these two coefficients of variation, we can conclude that Group 2 exhibit a greater variability or dispersion because the coefficient of variation for Group 2 is more than Group 1. In this example, we want to determine which dataset is more dispersed. We will find the coefficient of variation for both data to solve for this. By comparing the values of coefficient of variation, we can conclude that the age of accountants is more dispersed because the coefficient of variation for age of accountants is more than the salary of accountants.